Hello friends, welcome to Learner's Planet. Friends, this is our fifth session for inequalities, and precisely in this session we'll be taking logarithmic inequalities. We have already done 4 sessions on algebraic inequalities, and I hope now algebraic inequalities are clear, and we have yet to take more problems even on algebraic inequalities. Some challenging difficult level problems we will be taking very soon. Okay, so let's in this session we'll be discussing logarithmic inequalities, but you should definitely attend the sessions of logarithm before you attend this logarithmic inequalities, because basics of logarithm should be cleared. Okay, otherwise this session will be difficult for you to understand, right? So let's begin the session, and just be ready with your paper and pen. So two things we wished to take care while we are solving logarithmic inequalities. The first thing is base of the logarithm can never be 0, and it can never be 1, right? Base of the logarithm can never be 0, it can never be 1, and logarithm of negative quantities and 0 is not at all defined, right? So logarithm, if you wish to take of any quantity, then it should be positive only, neither 0 nor negative, exclusively positive quantities only. So logarithm is defined for positive quantities only. Okay, so this we have already discussed in detail in our logarithmic session, so do attend them, and let's see. So this is the first question, very first question, that is from CAT 2019 paper. Let a be a real number, then the roots of this equation are real and distinct. We are looking for real and distinct roots. So this is a quadratic equation, right? If the roots are real and distinct, that means b square minus 4ac should be, it should be what? It should be equal to 0, right? No, it should be only greater than 0. It can neither be less than 0, it can nor be equal to 0. It has to be just greater than 0. Even you cannot have greater than equal to sign, right? Because if you have greater than equal to sign, that means there is a possibility of the roots to be similar, right? But we are looking for exactly real and distinct. That means b square minus 4ac is exclusively greater than 0, right? So b square minus 4ac is greater than 0. So b square is what? 16 minus 4. A is 1, that is coefficient of x square, and c is log a to the base 2, and that's a negative. So just make it positive, log a to the base 2, and that should be greater than 0. So I can say log a to the base 2 is equal to minus 4, right? Minus 16 divided by 4 is minus 4. It has to be greater than. So minus 4 can be written as log 2 to the base 2 raised to minus 4. Basically it is 1, minus 4 into 1, and 1 can be written as log 2 to the base 2, because on the left hand side we have the base as 2. So on the right hand side I am taking an expression which is having the base as base of the logarithm as 2. Okay, so 1 log 2 to the base 2 is 1. That means you already know this basics of the logarithm, right? But I have minus 4 over here. So what I can do is so the number before the logarithm, it goes onto the power. It can be written as like this. Okay, so minus 4, I am taking that to the power. Now what is happening? If we take antilog of both the side, because in both the sides we have base as a logarithm, so a has to be, and base is greater than 1, right? If the base is greater than 1, that means the sign of inequality will be maintained, right? If base is less than 1, in that case the sign, when we take antilog, the sign of inequality will be reversed, right? That in that case a will be less than 2 raised to minus 4. But here we have the base as more than 1. That means a has to be greater than 2 raised to minus 4, or I can say 1 by 16. Right? So what is your answer? A is greater than 1 by 16. The problem is very simple. If you know how to solve logarithmic inequality and what is the condition to be put over here, you can solve this problem in just 30 seconds. Right? And this is a problem from CAT 2019 paper. So I hope that's clear to you. One more problem based on logarithmic inequalities from the same paper 2019. Square root of logarithm of 4x minus x square by 3. If x is a real number, then we have to find out the possible values of x, right? So since this quantity, this expression is under square root, so what we have to do? Log 4x minus x square by 3 should be greater than 0, and it can be even equal to 0, right? So I can write it log 4x minus x square by 3 should be greater than equal to log 1. Right. Now, when you are not given the base of the logarithm in calculus, you can use the base e, and in normal arithmetic calculation, you can use the base as 10. Both of them are greater than 1. Right. E lies between 2 to 3 and 10 is already greater than 1. So, you can use the base as greater than 1. Right. So, here now I can take anti-log. So, what I can do is I remove the log from the both the sides. 4x minus x square by 3 minus 1, that should be greater than 0, right? Now we just it has been converted to a normal inequality, that is algebraic inequality. So just take LCM. So here it will be 4x minus x square minus 3. So I can write down x square minus 4x plus 3 divided by 3 should be less than 0. That means this expression should be less than 0. Because in the denominator we have 3. So 3 cannot be less than 0. So that means this expression has to be less than 0. So this is x minus 1, x minus 3, and it should be less than 0. So 1 and 3. That means x should be between 1 to 3. Okay. So while you are defining the range, need to be careful that no expression should be there in the denominator which converted to 0 because of x if it takes these values 1 or 3, right? But we don't have any x in the denominator, so in this particular question no need to worry. Directly you can say x lies between 1 to 3. Clear? A very simple question from CAT 2019 paper, right? So first thing you should be knowing, the expression under the square root should be greater than equal to 0, and 0 can be written as log 1. If the base is not given, you can take any base, e or 10, doesn't matter, both of them are greater than 1. If the base is less than 1, then the sign of inequality will be reversed. We will be taking the problems of that also, no need to worry. After that, just solve it as a normal algebraic inequality, right? Now let's take this question. How many integral values x can take if y is real? And here the base of the logarithm is 0.4, that is less than 1, right? So let's see how do we solve this problem. So once again, the expression under the square root should be positive. So logarithm of x minus x square to the base 0.4 should be greater than equal to 0, right? Now 0 can be written as log 1. But base we will keep same. For any base, if logarithm of 1 is 0, right? So 0 can be written as log 1 to the base 0.4. Now since now we can take antilog of both the sides, but the sign of inequality will be changed because the base is less than 1. That means x minus x square is less than equal to 1. That means x square minus x plus 1 is greater than equal to 0. Now this expression is always positive, right? So according to this expression, x can take any value, right? Because b square minus 4ac is less than 0 over here, right? So this expression will always be positive. It will never be equal to 0, but it will always be positive, right? So x can take any value. So we cannot define how many integral values because x can take any value. So infinite. So this is the first part of this question, but question has not been completed over here because as I've already told you, logarithm of negative quantity is not at all defined, right? So we have just solved that this entire thing should be greater than equal to 0, but logarithm that is of x minus x square, that should be well defined, right? For that, whether base is 0.4 or any other base, it really doesn't matter, but logarithm of negative quantity or negative expression is not defined. So x minus x square should be greater than 0. Even it cannot be equal to 0. It has to be greater than 0, right? Here x can take all the values from minus infinity to infinity, right? Here x minus x square should be greater than 0. That means x square minus x should be less than 0. That means x minus 1 should be less than 0. So 0 to 1. X can take values between 0 to 1 only. Neither 0 not 1, just between 0 to 1. Now we don't have any integral value between 0 to 1. So x can neither take 0 nor can take in nor it can take 1, and between 0 and 1 we don't have any other integer. So how many integral values x can take if y is real? Not even a single. 0, right? So this sort of problems can be asked in theta problems. So from here, if you complete the question till over here, so you can answer, maybe if the multiple choice question is there, so you can answer infinite values x can take so many, whatever, right? Whatever the option according to you choose. So if you miss this part, this is really important part. Okay, if you miss this part, you will end up making this question wrong. Okay, so be very careful. In algebraic inequalities, we were solving this much part only, but in case of logarithmic inequalities, we just have to see the logarithm should be defined, is defined only for the positive quantities. Okay, so here we have to take care that x minus x square should be greater than 0, right? So that was an important part, right? So here we have discussed two concepts. When the base of logarithm is less than 1, the sign of inequality is changed while we are taking antilog, and logarithm of a positive quantity is only defined, negative quantity not defined, right? So ultimate answer is 0. I hope that's clear to you. Now again in this question we have to find out the integral values of x for which y is real, right? So here the first step is the entire expression under the square root should be greater than equal to 0. So log base 0.3 x square minus 5x plus 7 should be greater than 0, greater than equal to 0. So log 0, I'm just writing it as log 1 to the base 0.3, right? So x square minus 5x plus 7, if I take antilog, 0.3 is less than 1, so sign will be changed. Okay, so here x square minus 5x plus 6 is less than equal to 0, so I can say x minus 2, x minus 3 less than equal to 0. So 2 and 3, x belongs to 2 to 3, both of them as well, right? Now this is the first step. Second step is that means x can take a value as 2 and 3 both, because 2 and 3 both of them are included. Okay, now we have to see logarithm should be defined only for the positive quantities. So we have to check x square minus 5x plus 7 should be greater than 0 only. Okay, now roots of this equation are not real, right? B square is 25 and 4 into 7 is 28. So B square minus 4AC is less than 0. That means roots of this equation are not real. That means this quantity is always positive irrespective of any values of x. Okay, so we don't have to calculate any favorable values of x for this, but for this entire expression we have the favorable values as 2 and 3 both, right? So x can take only two integral values, that is 2 and 3. Okay, then only this inequality will be satisfied. Otherwise this particular part is satisfied for all values of x, right? So what is the answer? How many integral values x can take? Just 2. That is 2 and 3. That's it, right? Now let's solve this one. Again, integral values of x we have to find out. So the very first step is the expression under the square root should be greater than equal to 0. So log x square minus 9 to the base 0.5 plus 4 should be greater than equal to 0. So it should be greater than equal to minus 4, right? Now minus 4 can be written as base, and 1 can be written as log 0.5 base 0.5. So this minus 4 will go to the power of this. Okay, 0.5 raised to minus 4. Now what you can do is you can take antilog, and since the base is less than 1, the sign of inequality will be changed. Okay, so it is 0.5 raised to minus 4, so I can take it as 1 upon 0.5 raised to 4. Okay, so precisely it is 1 upon 2 raised to 4, that means 1 upon 2 raised to 4, so it is actually 2 raised to 4, that is 16. So x square should be, or we can say x square minus 25 should be less than equal to 0. So x minus 5, x plus 5 should be less than equal to 0. So from minus 5 to 5. All the values from minus 5 to 5, right? So x can take inclusive of minus 5 and 5, right? So x belongs to minus 5 to 5. Now the second step, we have to check that x is not defined for negative quantities. So x square minus 9 should be greater than 0. So that means x minus 3, x plus 3 should be greater than 0. That means x should be less than minus 3 or x should be greater than 3, right? Now we have to club both of them, right? Because ultimately our answer should satisfy both the inequalities. Okay, so let's club them. So I mark the points. This is minus infinity to minus 3. Then here we have, oh sorry, minus 5 I write over here. Then I write minus 3. Then I write 3, then 5, then infinity. Okay, so just a moment. Solution to this is minus infinity to minus 3. So minus infinity to minus 3. Union 3 to infinity. Okay, and solution to this is minus 5 to minus 4. This is actually minus 5. So minus 5 to 5, sorry. So it is minus 5 to 5, right? Now we have to check the portion which is clubbed, which is a combination of red line and this multicolored line. So it is from minus 5 to minus 3. Minus 3 is not included, but minus 5 is included. Union 3 to 5. So again 3 is not included, but 5 is included. Okay. So now how many integral values we have? From minus 5 to minus 3, we have minus 5, minus 4, 2, because minus 3 is not included, but minus 5 is included. Then from 3 to 5, 3 is not included, 4 and 5, 2 values. So in all we have 4 values which x can take, for which y is real, or we can say this expression is defined, right? So I hope this thing is clear. If you are not clear for the first time, just replay the session. So because this is really going to be important question, because 3 concepts we have merged over here, right? The expression under the square root should be positive. Then when you are taking the antilog, the sign of inequality will be reversed because the base is less than 1. Then the clubbing of the answers, clubbing of the solutions. Okay. Now let's see this question. So here we have y is equal to log of 1 minus log of x square minus 5x plus 16. Okay, so we have to find out the integral values of x for which y is real. Okay, so the first thing is we have to check that this expression, for first we are considering this logarithm, so this quantity should be positive. So 1 minus log of x square minus 5x plus 16, it should be greater than 0, not even equal to 0, it should be greater than 0. Okay, that means I can say log of x square minus 5x plus 16 should be greater than 1, right? So now 1 can be written as log 10 to the base 10. Okay, here I am assuming the base is 10. So since this is arithmetic calculation, so base is 10, so log 10 to the base 10. Now since base is greater than 1, the sign of inequality will be maintained. So x square minus 5x plus 16 is greater than 10. So I can say x square minus 5x plus 6 is greater than 0. So here it is x minus 2 x minus 3 is greater than 0. So x should be between 2 to 3. Okay. Neither of them is included. So this is the very first condition. Okay. So we are not getting in fact even a single value, integral value which x can take, right? So though it we don't have to solve it further. But still, let's see. Now the second step is we want x square minus 5x plus 16 is greater than 0, right? X square minus 5x plus 16 to be greater than 0. Now b square is 25 minus 4 into 16, that is 64, so that is less than 0. That means roots are not real. So for any value of x, this expression will be positive, right? So here x can take any value, but for this entire expression, x can take values only between 2 to 3, right? So since 2 and 3, both of them are not included, so x cannot take any other value, any integral, other integral value. We don't have any other integers between 2 and 3, right? So x cannot take any integral value. So what is the answer? 0 integral values x can take. Okay, so it's a two-step question. Should be very clear to you, very important. Now I'm sure you can solve the problem on your own. So just pause the session, try to solve this problem on your own, then match your answer and solution with mine. So here logarithm of negative is not defined, so 3 minus 2x minus x square should be greater than 0. So I can say x square plus 2x minus 3 is only less than 0. Okay, so here it is x plus 3, x minus 1 should be less than 0. So x should be between minus 3 to 1, right? So if you are looking at the integral values, x can take minus 2, minus 1, 0, 1, that's it, or not even 1. Okay, so x is these three integral values, minus 2, minus 1 and 0, because minus 3 and 1 both of them are excluded. Now the second case is, since we have the root x in the denominator, so we just have to satisfy this inequality also. So root x, since the x is the quantity that is under the square root, so x has to be greater than equal to 0. But since it is in denominator, so x has to be only greater than 0. It cannot be equal to 0. So if we club both of them, all the three values of x which we have derived from here will be excluded. Okay, because here we have the three values of x, minus 2, minus 1 and 0, and here we have x is greater than 0, so x can neither be minus 2, minus 1 or 0, right? So no integral solution. That means precisely x cannot take any integral values. Okay, I hope it's clear to you. Now let's see this question. It's combination of algebraic and logarithmic inequality. So here x plus 5 should be greater than 0. So that means x should be greater than equal to minus 5. So x is from minus 5 to infinity. Minus 5 is included. Here 9 minus x should be greater than 0. Only greater than 0, not even equal to. That means x is less than 9. So x is minus infinity to 9. Okay. Now we have to club both of them. So here minus infinity, here we have minus 5, here we have 9, and here we have infinity. So this is minus 5 to infinity, this is the range, and minus infinity to 9, so this is the range. So your favorable answer is from minus 5 to 9, right? And here minus 5 is included, but 9 is not included. Okay, so how many integers we have? From minus 5 to 9 we can calculate. Minus 5, minus 4 till 8. Okay, so that's pretty simple. I hope it is clear. So once again friends, in this question there is a twist. We don't want even 0 in the denominator, right? So if we have x as 8, then 9 minus 8 will be 1 and log 1 will be 0. Right? So from all these values you need to delete x. Okay? 8 I mean. So x can take all the values from -5 to 9, but precisely in that case we just have to count up to 7 because 9 is already excluded and 8 we have just excluded. So from -5 to 7. So that was an important twist. Okay. So that's why I have taken this problem where we are clubbing algebraic and logarithmic inequality, and logarithm is in the base, in the denominator. Okay. So all the facts, all the points you have to consider while you are solving logarithmic inequalities. Now here in this question we have to find out the range of real values which x can take. Okay. So here no square root, nothing, but we have an expression in the denominator that is 2x plus 5. So we have to take care for that. Now on the right hand side it is 1. Here on the left hand side the base is 2. So 1 can be written as log 2 to the base 2. Right. Now since base is greater than 1, the sign of inequality will be maintained. So this expression should be less than 2. So I can say this expression should be less than 0. Okay. So x minus 4 minus 4x minus 10 upon 2x plus 5 is less than 0. So here it is x minus 4x, so it is 3x, and minus 4 minus 10 is minus 14. So I take plus 14 by 2x plus 5, and it should be greater than 0. I am multiplying the numerator by minus, so sign of inequality will be changed. So it's minus 14 by 3, and here it is minus 5 by 2. So x should be from minus 5 by 2 to infinity, or minus infinity to minus 14 by 3. Okay. None of them is included. Right? Now the second part, logarithm of negative is not defined. So x minus 4 upon 2x plus 5 should also be greater than 0. Right? So x minus 4 by 2x plus 5. So I just can mark it 4 and minus 5 by 2. So this should be greater than 0. So 4 to infinity, minus infinity to minus 5 by 2, union 4 to infinity. Right? Now we have to club both the results. So mark all the points. Here it is minus infinity, then minus 14 by 3, then minus 5 by 2, then 4, then infinity. Okay. So here it is minus infinity to minus 14 by 3, and minus 5 by 2 to infinity. Okay. And for the expression above, we have minus infinity to minus 5 by 2. Okay. And then 4 to infinity. So the common range is 4 to infinity and minus 14 by 3 to minus 5 by 2. Right? No, I'm sorry, minus infinity to minus 14 by 3. So the favorable range is minus infinity to minus 14 by 3, union 4 to infinity. Okay, so this is your final answer. So this is the answer when we are solving this inequality. Okay, and this, the next step is when we are making this expression to be greater than 0, because logarithm of negative is not defined. So while you are solving the logarithm based inequalities, you have to take care of both the things. You need to check the expression which is logarithmic expression should be greater than 0. Okay. So finally we have clubbed both the solutions. So I hope that's clear to you. So this is the final answer. So friends, I hope logarithmic inequalities are now clear to you. In our next session, we'll be taking very, in fact, I can say important questions or challenging questions. So do attend all the sessions of inequalities before you come for the next session. Okay, and that will be really challenging one. Right? So I'll see you in the next session once again. And yes, do not forget to subscribe the channel. You can even join the channel if you want the regular updates of the videos and full length videos if you wish to say wish to see without advertisements and all that, you can join our channel. Okay, you can mail your doubts. I have already given my mail ID in the description, so can be in touch with me. Okay, so I'll see you in the next session once again. Bye bye.